This is day 2 of 6-2. We're gonna learn how to find different values that are on the unit circle, or actually not on the unit circle, but different trig functions using our calculator, using radians now instead of degrees. So when you're using your calculator for this chapter, always remember to make sure it's in radians. If you've cleared the memory, the default is radians. So our first example is, I've already written the answer here, so let's cover it up for a minute. So for this part of the notes, all you're going to do is use the cosine, sine, and tangent button the way they are. We are not using the inverse function yet. So this measure that's right here after the word cosine is going to be your angle measure, and it's in radians. Before, when we did this in chapter 5, you would have had a degree measure here. However, the process is the same. You are going to touch that cosine button. It'll open the parentheses, and in the parentheses you will put 1.85. You will then hit enter, and then you will get a really long decimal. We are going to round that decimal to 4 decimal places. So negative 2.756. Now, remember, this measure that's in here is in radians. The answer that we're getting here is the ratio of the adjacent over the hypotenuse. Now, we don't have those numbers. That's why we're using our calculator. Now, again, to see if this makes sense, remember our all students take calculus trick. Remember, 1 radian is about here. 2 radians are about here. So that would tell me that 1.85 radians is somewhere in quadrant 2. So getting an answer that's negative for cosine makes sense, because the only thing that should be positive in quadrant 2 is sine and its reciprocal. So my answer makes sense. So for this, as long as you're confident with putting in and touching the cosine button and then putting this decimal in there and hitting enter, you just write down the answer that's on your calculator. The next question, number 2, same thing. There is a button that says COS. It's not until we get to the questions that are going to have cosecant, cotangent, and secant where we're going to have to use 1 divided by. But for any of the questions that have sine, cosine, or tangent, all we do is touch that button, COS, and then put in the decimal. So we're going to find the cosine of 0.3425, and we get approximately 0.9419. The next one, same thing, no reciprocal functions here. All we need to do is touch that cosine button, and in it, the parenthesis, you're going to put 0.5149. And this will be approximately 0.8703. Realize that this number here is about half a radian. And we know that 1 radian's in the first quadrant, so getting a positive answer from the first quadrant is reasonable. The next one is cotangent. Now, we don't have a button that says COT, so this is where we have to use our reciprocals. You need to remember that the cotangent of any radian measure is 1 over tangent. So here I'm going to do tangent. I'm going to do 1 divided by the tangent of 1.3209. Hit enter, and you should get 0.2552. Good on that? Yes.
If it ever was like not reasonable
Uh-huh.
about like if it's in the red quadrant or negative or positive, like what do you do?
Well, what'll happen is right now you're going to be able to find the answer. So we're just doing like a double check, and that double check of reasonable is I would go back and make sure you put it in your calculator. Does that make sense? It won't be till the, where we would get impossible, and impossible is if they gave us something that didn't make sense. All right, the next one is also a reciprocal. Secant is the reciprocal of cosine. So here I'm going to do 1 divided by the cosine of negative 2.9234. 2.9234. Let's make that appear. And this will approximately give me negative 1.0243. Again, a negative 2.9. Again, if you think about where your radian measure should be, this would be 1, negative 1. This would be negative 2 if you're going clockwise. So 2, and then remember over here is the 3, and it's also negative 3. So if you're going to look for negative 2.9, it's ending up in this third quadrant where only tangent is positive. So getting a negative number for secant, it makes sense. Don't automatically assume that because you're putting in a negative, you should get a negative answer. This negative is only indicating what quadrant it should be in. Okay, so let's keep going here. 2 more. Both of these are direct calculator, no reciprocals here. So you would touch the cosine button and then negative 5.2825, and you get approximately 0.5397. Notice on this one, we started out as a negative number, but we ended up with a positive answer. And the reason for this, again, negative 5 radians is about here. So if I were to go around, 5.2 negative is going to end up somewhere in here, which is the first quadrant where everything is positive. So again, if you needed to see this, remember from the very first day, and let me label this. So like this would be about 1 radian, 2 radians, 3's over here, 4's over here, 5, and then 6. Now if we went clockwise, this would be negative 1, negative 2, negative 3, negative 4, and this 1 is negative 5, and then over here could also be negative 6. So you could just memorize the main integer radians, and then if you're going clockwise, you start counting with negative 1, negative 2, and so on. For number 8, this is about 6.4 radians. Now remember that pi, the approximation that you were used to in geometry, was about 3.14. So if you times 2 times 3.14, you got 6.28. So that full circle is about 6.2, almost 6.3 radians. So if I'm trying to graph 6.4, notice that that's going to be a full circle and then a little bit more. So you can see you're ending up in that first quadrant where everything's positive. So once I do this in my calculator, I already can anticipate that I'm going to get a positive answer. And this gives me about 0.1944. You would just hit tan and then put this number and then hit enter. Make sure you're in radians, not degrees. Everybody got that? Did it work? Okay, now we're going to switch. Now we're going to actually do inverse function, so that second key to get the angle measure. So this one, you were given the angle measure in radians and you had to find the value. Now you're given the value and you have to find the angle measure. Now notice here, my restriction on my interval, remember before, this was from 0 to 360. Now notice it's from 0 to 2 pi, and again 2 pi is equivalent to 360. So it's still the full circle, and again we still have to bring in our all students take calculus to figure out where our two answers are going to come from. So this was like finding theta in the chapter 5 test. So for this one, you can either eliminate the quadrants you want to at the beginning, or you can do the calculator part first. Either way. So if I eliminate my quadrants, that's going to save time on my calculations. So I know cosine needs to be positive in this quadrant and in the first one. So this tells me that I don't need to find out any angle measures for quadrants 2 and 3. Now, let me just show you the math in terms of radians versus degrees that we have to do for this chapter. So remember, in quadrant 1, that is always our reference angle. To find the measure of the angle in quadrant 2, remember in chapter 5 how we did the 180 minus the reference angle? In this chapter, instead of 180, we're using pi. So we'll do pi minus the reference angle, and that will give us the measure for angle 2, or quadrant 2. To find the measure for quadrant 3, remember we used to do 180 plus the reference angle. Now we'll do pi plus the reference angle. And lastly, for quadrant 4, we used to do 360 minus the reference angle. Here we're going to do 2 pi minus the reference angle. So I'm going to go ahead and calculate my reference angle by using my inverse function. So on your calculator, you're going to press the second key or your shift key, whatever button you have, and then touch cosine, because that's the function they want. And then it'll open up cosine to the -1, indicating it's an inverse function, and then put in the value, 0.7826, hit enter, and the reference angle that they're going to give us is about 0.6719 something. We're going to round it to 3 decimal places, so 0.672. That is my reference angle. That is the measure of the angle in quadrant 1. Okay, again, remember we already eliminated 2 and 3 because remember cosine's negative in those. So here, I'm going to take my 2 pi and I'm going to subtract 0.672. So you can just hit 2 and then the pi button and then subtract 0.672. Once you do that, you should get 5.61. And these are going to be my 2 angle measures in radians. So S is equal to 0.672 and 5.61. Notice it is in my range because remember the range was from 0 to about 6.28. We're going to do the next one. Coincidentally enough, it's still the same trig function and it's positive. So again, the same 2 quadrants for this one. So again, first let's eliminate. So all students take calculus. I want a positive cosine. So that tells me to get rid of these 2. And now I can figure out my reference angle. And to get the reference angle, again, you're going to hit the second key. So cosine -1 opens up. We're using inverse functions. And in the parenthesis, you will put the value. Hit enter. And you should get 0.252. Again, this is your reference angle for quadrant 1. And again, we want quadrant 4. And remember to get quadrant 4, I subtract that number I just got from 2 pi. And again, this is all calculator here. Once we do that, we should get 6.03. So my 2 values for S, 0.252 and 6.03. Pretty good. Now we're going to actually see the reciprocal. So the 2 functions I just did were both cosine. There was a button for cosine. The next example, 3, is going to be cotangent. For cotangent, we need to know that the tangent of S is really equal to 1 over cotangent. So when I go to put it in my calculator, I'm still going to hit the second key. So it opens up tan to the -1. And then in the parentheses is where you do the 1 divided by. And the value that's there. Once I hit enter, this gives me my reference angle. So again, let's draw my all students take calculus here. Again, my reference angle goes here. And now I want cotangent to be positive. So I know that's where the T is for tangent. So I know I need an answer from here and from here, because cotangent would be negative here and here. So now I need to do the math using that reference angle. Remember, to get that measure, it's pi plus the reference angle, 1.28. Once I do that math, I get 4.42. So the two measures of S are going to be 1.28 and 4.42. And these are all radian measures that I'm giving you, or that we're getting as our answers. Again, these are all radians. All the questions I've done, starting, I think, at example 9. And this should actually say number 11. My numbering got off. All right, next one is also a reciprocal. Cosecant is the reciprocal of sine. So again, second key, so it opens up the inverse function, sine to the -1. And then in the parentheses, you're going to do 1 divided by 1.0219. You're going to hit enter. This will give us our reference angle from quadrant 1. Add in our all students take calculus. Again, we're looking for cosecant, which is the reciprocal of sine, to be positive. So I know I'm looking for something in this quadrant and in this one. These two are out. Remember to find the measure in quadrant 2. It will be pi minus 1.36. Once I get that number, it's 1.78. So S is equal to 1.36 and 1.78. Now the last example, it's a little tricky, but my advice to you is, because when we did this in radian and degrees, when we had a negative reference angle, I know it confused some people. So to avoid this trouble, when we do this in radians, anytime you're using the inverse function and working backwards, don't enter this number as negative. Even if it's given to you as negative, make it positive. Right now, all this number is telling us right now is what quadrants we can eliminate, or where we need to look for it. So before I even do anything, all students take calculus. I need a negative sign value. So I know sine's positive here, get rid of it. It's also positive here. So my two angle measures I'm looking for are in these two quadrants. So in order to get a positive reference angle, when I go to do this, I'm going to hit second sign. But instead of putting in negative 3.3425, I'm going to put in positive. If you put it in as a negative, you're going to get a negative 0.3495, and just know to move it up to quadrant 1 and make it positive. So it's easier if you just put in, for all these working backwards questions, when you're using the inverse function, put in the number as a positive number. So once I do this, I get a positive reference angle, and it's actually going to be 0.3495. I'm going to round this even more and make it 0.35. So this is my reference angle. Notice in my answer, I don't want to list that. Some of you did this on the last test. I only want you to list where it's a valid angle measure. So, and that's only going to be quadrant 3 and quadrant 4. So to get those measures, you're going to do pi plus 0.35, and you would get 2.49, and then over here 2 pi minus 0.35, and then this will give you 5.93. On the test, it'll specify what place to round to. So S is equal to 3.49 and 5.93. So your homework tonight is actually the 6-2A. The homework that's listed here on this slide is actually due on Friday. And if you look in Canvas, it's listed as 6.2B. Now, for those of you who like to work ahead, there is another assignment that says 6-1 and 6-2 extra practice. I don't have anything yet to give you. So for now, you're doing 6.2A. It's due tomorrow. And then if you've already done 6.2A, you can work on the 6.2B because that's what I just taught you. And this is due on Friday. So tomorrow in class, we will review 6.2A's homework, and I'll work out any problems you need to see from it. And then I'll answer any questions from 6.2B also. But your homework officially is going to be 6.2A tonight, and tomorrow night 6.2B. And again, start memorizing that unit circle.